Hello, I'm Dr. Younger, Director of the Neuroinflammation, Pain, and Fatigue Laboratory, and I want to tell you about my plan to fight brain inflammation. Now, if you follow this channel, you know that the neuroimaging studies, the MRI and the PET studies, clearly show that brain inflammation contributes to conditions like ME/CFS, fibromyalgia, and long COVID. And every time I do a video in the comment section, someone asks, okay, well, what are you going to do about it? So here's the truth. Right now, there is not a single treatment, pharmaceutical or otherwise, specifically designed to target microglia in the brain and reverse brain inflammation. Every drug or botanical or intervention that helps neuroinflammation does that as a secondary effect. It's not the intended function of the treatment. For example, low-dose naltrexone. Naltrexone was designed to block opioid activity, and it's really good at doing that. It's fortunate that it can also reduce brain inflammation, but the fact is that it's doing other things that limits the utility and it limits the dosage we can give. So what we need is a treatment that can cross the blood-brain barrier, effectively hit the critical receptors on aggravated microglia, and reverse the inflammation in the brain. To my knowledge, not a single human has ever taken a drug designed to specifically do that. But let me talk about a candidate to fill that role. Now, we've known for quite a bit over 10 years that dextro-naltrexone exerts the properties needed for an effective microglia modulating drug. It has excellent supporting scientific evidence from Dr. Linda Watkins and Mark Hutchinson, their colleagues, and other researchers. Now, by the way, if this drug is new to you, you've never heard of it before, check out the video that I did about it a while back. I'll link to it at the end of this video. So I'm not going to go into how it works pharmacologically in this video because I've already done that. The main point is that it has been at the top of my list of pharmaceuticals that I want to trial in ME/CFS and other conditions for a very long time. I was writing about the need to develop it way back in like 2012 when I was at Stanford and doing work in that area. And I've been waiting for years for someone to synthesize this compound for human use and get through the FDA process so I could use it in human patients. I didn't feel like it was my place to do that work myself. I'm not a synthetic chemist. I'm not a compound manufacturer. I'm not a preclinical scientist. I'm not in the business side of medicine. I get involved when it's time to run studies on human patients. And that's way down toward the end of drug discovery and testing. So I waited and waited and waited. I was calling for it. Other people were as well. But it never happened. No one ever took dextro-naltrexone and produced it for human use, despite the promising animal model studies. Why did no one move forward with dextro-naltrexone? It's probably because there's no chance to get a patent to protect the product. So if there's a business and they're working with this compound, they couldn't protect their profits. They would do all the work for developing, and it's very expensive. And then once they're done, someone could come along and make and sell it themselves. Now, the reason a patent can't be secured for dextro-naltrexone is that I and other scientists have shared the idea in published scientific articles, which is called prior art. And that means the idea is in public domain and it's no longer novel enough for patent protection. To get something protected, you have to keep it secret, basically, until it has the patent. And dextro-naltrexone is already being discussed publicly, so it doesn't meet that criterion. So an application to the patent office would be rejected in the United States, and there would be no legal protections for developing the compound. That makes dextro-naltrexone unlikely to be a good business venture, and so investors are unlikely to contribute money to develop the drug. And again, it is very expensive to get a compound through all the stages up to use by patients. Now, it's frustrating, but that's how the law in the US and many other countries is. So I've decided I'm going to do it anyway. I'm going to take the lead in shepherding this compound through all the financial and the technical and the regulatory and the scientific hurdles. I've identified key players needed to get through the stages. And now I'm just going to raise the funds to get it done. It's going to be a long road. It's going to be an expensive one. And this is very high risk. Most treatments that look great in basic science fail when they're tested in patients. That's just the way it goes. So that could happen with dextro-naltrexone as well. We can't know until we try. So now I'm contacting potential collaborators who want to see this happen. They won't be investors because this isn't a business, but there'll be donors who believe a treatment for brain inflammation is desperately needed. It's going to ultimately take around 5 million, that's my projection, US dollars, to get this done and through the kind of second level clinical trials in patients. And that's a lot of money. I haven't made any plans to crowdsource this effort. I'm not exactly how to do that anyway in the context of university research. And I'm not doing it right now because it's just so much money. It feels out of the scope of crowdsourcing, but it's possible that could change in the future. I just haven't looked into it yet. Now, what I have done in the meantime, though, is I've put my lab's donation page in the description of this video. And this link that you can see, this has been publicly available for about 12 years. Every lab has one. And so anyone's welcome to donate to my lab at any time, and they can earmark the funds for dextro-naltrexone development. That's fine. This goes through my university, and so it's a tax-deductible donation. And then it goes into my lab's gift account, and it's under my control for research purposes. So it's a good way to contribute to the science. So you can absolutely contribute in that way if you wish. But if you're already donating to one of the nonprofits for ME/CFS or fibromyalgia or gulfur illness or long COVID, keep doing that. I don't want to take funds away from the important work that they're doing. Now, I'm probably not going to talk about dextro-naltrexone on this channel very much because the project won't be relevant to most of you until we have data from patients, but I'll give brief updates whenever there's a major move in the project. So let's get started. I've got a very busy week ahead of me, and I'll catch you up on everything going on very soon. And do check out that video again, my earlier video on dextro-naltrexone, which is video number 13, I think, if you want more information on how dextro-naltrexone actually works. So that's it for now. I will be back soon.